All right, so let's continue on number 7. We got to here. And for those of you who are still struggling a little bit with your 45, 45, 90s, let's go ahead and talk about something. Remember, the rule is x, and then x squared root of 2. In other words, we got to multiply one of these sides by the square root of 2 to get the hypotenuse. Let's make sure that works. And because this is negative, I don't want to confuse anyone. I'm going to choose this one. If we multiply this by the square root of 2, do we get 2? Well, what's the square root of 2 times the square root of 2? Well, that's the square root of 4, which is what? 2. So does it work? Yes, which verifies this little angle in here 100% needs to be a 45-degree angle. Now, a lot of people would pick this maybe, negative pi over 4, because it's like, wait, what's wrong with that? Well, really, there's nothing wrong with this. It's just that these limitations are saying, hey, no negatives. And your answer has to be greater than 270, less than 360, so that would eliminate that as a possibility. So let's just figure out where or how far we spun our spinner. Well, that would be 315 degrees. Where did I get that from? 360 minus 45. So there's 315. Unfortunately, they don't have any of those listed. Well, there's a couple ways to figure out how this or what this is in terms of radians. I think to keep it simple, I'm going to remember that pi over 4 is equal to 45 degrees. Now watch this. I need to go, every chunk of 90 degrees is 2 of these. So what I'm going to do is I'm going to go, all right, 1, 2, 3, 4, 5, 6, 7 45s. So my answer is going to be 7 pi over 4. That equals 315. And so there it is right there, letter B. That one's pretty involved. All right, number 8 gets into some interesting stuff here. Angle C is 90, so let's go ahead and give ourselves a little picture. And that's my 90-degree triangle right there. Angle A is 71. I'm just going to call this, I should have drawn my triangle bigger, sorry. There's 71. And let's stop a second. 90 plus 71 is 161. So that means this must be 19. I'm just going to take that little gift. Will we use it? Maybe, maybe not. It says let C, which is the hypotenuse, be 9. And it says find B, which is right here. All right. So let's say a student did not think about that being 19 degrees. Then they would have to use this angle as their reference angle. And then they'd have to say, okay, well, this is my opposite side. This is my hypotenuse. So this must be my adjacent side. So I need to involve my adjacent side and my hypotenuse, remembering so, ka, toa. Which one involves my adjacent and hypotenuse? This one, cosine. So that tells me cosine of 71 degrees equals my adjacent side, which is what I want to find, over my hypotenuse. So now I got to pause this because I don't have a calculator. So what I need to do is I need to figure out what cosine of 71 is, 71 degrees. Now I'm going to show you guys something. You got to check your calculator once in a while. Now every calculator is a little different, but this particular calculator, you can see down here you got radians that's not highlighted, degrees that is. This is what you want. If you're going to type in 71 degrees, you better have it in degree mode. And so now I can figure out cosine of 71, hit enter, and say I'm going to round it to 0.33. So I get 0.33 equals b over 9. So now I got to multiply both sides by 9. So I'm just going to go times 9, 2.93. And you can see that's option A, staring right at us. All right. So with that in mind, let's go on to number 9. This says the length of the intersected arc, which remember is S, by a central angle of 5.5 radians, which is theta, in a circle of radius 24, which is r. So you can see, because we're using radians, we're going to use the formula S equals r theta. Now, if they gave us degrees, like 75 degrees or something, then you would use S equals pi r theta over 180. Be very careful with this because this is dealing with degrees only, and this is dealing with radians only. All right. So, because this problem's spoon feeding us in the direction to go here, let's take advantage of it. It says find the length of the intersected arc, S, where R is 24. I'm just going to put things in order. And my central angle, which is theta, is 5.5. So, I'm going to do this in my head. 24 times 5 is 120. Half of 24 is 12, so that'd be 132. And it's sitting right there, so 132 centimeters. Okay? All right, number 10. The point, -1, -3. Don't you dare continue before drawing yourself a little picture. And make this huge. -1, and I got to go down the square root of 3, which is like 1.7. So you got to make that look a lot longer, because the way you draw this drawing will help you. Remember, if there's a side that is the square root of 3 times the other side, this is looking a lot like a 30, 60, 90 rule, and it is. So I can assume that this is my 60 and this is my 30. And what would the other dimension be? Well, I take my short side and I double it. Now don't worry about the negative because my spinner's never negative, so that's 2. It says give the smallest positive radian angle measure. So are they asking for this 60? Because that would be letter C. And the answer is no. They're asking how far did you have to spin your spinner to get there? Well, that'd be 180 plus 60, which is 240. And you're looking at all these and you're wondering what's going on here. Wish they would have just put it in degrees. Well, they want you to understand how to convert this to radians. Now, here's the clue. Question is, does 60 degrees, which is pi over 3, does 60 go into 240 evenly? Yes. How? Times 4. So if 60 degrees equals pi over 3, then 240 must equal pi over 3 times 4 is also. So 4 pi over 3, which is option A. And let's continue. Identify the one angle that is not coterminal. Remember, coterminal just means they ends in same. And when I say same, I mean exact place. So really, this problem is just a bunch of spinners. So let's start with this one. Okay? So we go -462, which means down. Now, we went 360, which means we have to go 102 more. So if we subtract 360, we got 102 more degrees in that same direction. Well, here's 90, which means I have to go 12 more, which would take me right about here. Okay? So this one right here is -462. I'm just going to keep track of all these until I find one that doesn't work. Now I need to spin it 438. Well, I'm going to grab this yellow 438. We'll start here because I always start there. Up 438, which means I got to go around a circle. See, I've gone 360, and that means I need to go 438 minus 360 would give me 78. I need to continue going 78 degrees, which would end right about here. So, obviously, these two are not coterminal. So I'm going to go to the next one and go, wait a minute, 78? That looks familiar. That means just take your spinner and spin it up here, and it lands right on top. Well, here's the deal, you guys. These two, These two are 100% coterminal. This one's not. So we can be rest assured that this is the one that's not coterminal with any others. So that would be -462. Now, if you're curious about this one, does it land here? Well, 360 plus 360 is 720. 720 plus 360, let me figure that one out real quick. I don't know why. 720, yeah, is 1080. So what I'm saying is, if we went this far, 360 times, let's go ahead and subtract 1080, and this would be 78 degrees. So you can see that this one would land right on top of that one as well. 798, if we subtracted 720, because that's 2 revolutions, that's like starting here and just going around once, going around twice, and then we'd have 78 left, and that would land here as well. So this one's clearly the one that is not coterminal with the others. All right, let's go on to this guy. Find the arc length, that is S, of a 30-degree sector cut, that's theta, from a circular disk of radius 8 inches. Well, I'm going to try to be somewhat accurate here. 30 degrees to me looks about like that. So there's my 30 degrees. And it's asking me to find S. That's not a 5, that's an S. And my radius is 8. As you can see, they gave this in terms of degrees. So back up to here, this is going to be my degrees only, so I'm going to go ahead and use it. Yes, I can convert this to radians, but just to practice this formula, I'm just going to use it. So we're going to go S equals pi times R times theta, which is 30, all over 180. Now here's something interesting that happens that students do once in a while, and it gets a little... Oh, I'm sorry, you guys. I wasn't even on the page. So S equals pi r theta over 180. Now here's something interesting that happens when students start whittling this down. In this, when we're finding the arc length, do not convert this to 180, because then you would go 180, 180, and you'd get 240. It's like these things don't even matter. When you use this formula, pi has to be 3.14 times 8 times 30 all over 180. So all I'm going to do to finish this is just crunch these numbers out. There's a few ways you could do this, but I'm just going to go 8 times 30 is 240. So 240 times 3.14 divided by 180, and I get 4.19. Okay? So 4.19. There we go. All right, getting to the end of this recording, so I better hustle. Number 13, it says find the acute angle theta in degrees and radians. That's why they have 2 blanks. So I'll go degrees here, radians here, so I don't forget. These are the little things that students make mistakes on. They don't read the question, and then they don't give themselves a reminder for later. That satisfies secant is the square root of 2. Well, here's the way you attack this problem. First of all, the square root of 2, again, is a huge indication that it's a 45, 45, 90 coming up somewhere. But what we have to realize is secant is the reciprocal of cosine. So if secant is the square root of 2 over 1, which is the way you should look at it, that means cosine is going to be 1 over the square root of 2, which, by the way, this would be my adjacent side. This would be my hypotenuse. So I take a look at a 45, 45, 90, and I ask myself, okay, let's take a little look. If my adjacent side's 1 and my hypotenuse is the square root of 2, that means this is 1, if this is a 45, 45, 90, which it is. And then I say, okay, well, how far did I spin my spinner? I spun my spinner 45 degrees, so that would be here. Now, what is 45 degrees in radians? Well, if you have it memorized, it's just pi over 4. What if you don't? Then you're going to have to go 45 degrees over 1. You have to multiply it by pi over 180. degrees, and remember the degrees cancel, and then 45